Hello everyone. I'm going to discuss about routing protocols. And what is routing? Routing is a process of moving packet from one network to another network. So for that we have routing protocols. Like this we have routing protocol like RIP, Routing Information Protocol, Enhanced Interior Gateway Routing Protocol, and OSPF, Open Shortest Path First, and Intermediate System to Intermediate System, and then we have Border Gateway Protocol. So I'm discussing about ISIS, Intermediate System to Intermediate System. So ISIS, Intermediate System to Intermediate System, and this ISIS was developed by ISO and is a protocol working between intermediate system to intermediate system. So like this, we have intermediate system in ISO terminology is router. So routing protocol works between the routers, IS to IS. So like this, we have routing protocol. What is ISIS? Basically, intermediate system to intermediate system was developed by ISO. And it is a dynamic routing protocol for ISO CLNP, Connectionless Network Protocol. And it was like later adopted by IP prefixes, like it can work with IP also. So that's why it is called as dual ISIS or integrated ISIS, right? And it is predominantly adopted by used by ISP environment, right? And similarities between OSPF and ISIS, because we know OSPF very well, we have been using OSPF. So OSPF and ISIS use both SPF algorithm, shortest path first algorithm, and it uses hello packet to form neighbor relationship and to maintain adjacencies, and it uses areas, right? And it is a classless routing protocol. It supports FLSM, VLSM, and manual summary like OSPF. It elects a DR to represent broadcast network, designated router, and it supports authentication like ISIS supports authentication like OSPF. Hello interval in ISIS is 10 second, dead interval is 40 second, right? And administrative distance for ISIS is 150, and it uses multicast address 224.00.20, 224.00.20, 224.00.21. And each interface between two routers, like each interface between routers gets a metric of 10 by default, and that 10 is the range, like it takes from the range between 0 to 63, right? And this 10 will be multiplied by number of hops, that is number of routers, right? And next we have OSPF and ISIS terminologies. In OSPF host, PC host, in ISIS terminology it is called as end system, ES, and router in ISIS it is IS, intermediate system. Link here it is called circuit. Packet, protocol, data unit, PDU, and designated router here it is called as designated IS. And backup designated router, there is no backup designated router in ISIS. It uses link state advertisement, and it uses link state PDU. Hello packet, it uses hello packet, and here it is ISIS hello PDU, right? And it uses database description DBD, and it uses complete sequence number, right? And here we have ISIS areas. The area boundaries fall on the link, not within the router. Thus, all the interfaces of a router will be on the same area, like this. It is not on the router, it is falling on the link, right? And then routers are characterized as level 1, L1, and level 2, L2 routers. So L1 router is similar to OSPF internal router, analogous to OSPF internal router. These are internal routers, like L1 routers. L1, L2 is similar to area border router. So this L1, L2 is similar to area border router. Like L2 backbone router, these are L2 routers, which is not connected to L1 routers, right? Like this, we have neighbors and adjacencies in ISIS. ISIS discovers neighbor and maintains neighbor relationship adjacency by using ISIS hello PDU, right? Hellos are transmitted in every 10 seconds. By default, we can manipulate these timers. ISIS forms separate adjacencies for L1 and L2 routers. L1 routers forms L1 adjacencies with L1 and L2 routers. L2 routers form L2 adjacencies with L1 and L2 routers, and neighboring L1 L2 routers form both L1 and L2 adjacencies. Any adjacency process is refreshed in every 30 minutes. So like this, L1 router will form adjacency with L1 router. This L1 router, it will form adjacency with L1. L2 router will form adjacency with L2 routers, right? And like this, we have L1 area adjacency, ISIS area adjacency. L1, L2 routers maintain two databases, one L1 database and L1 database and another L2 database. L1 routers have no knowledge of router outside the area and maintains L1 database. L2, and to send traffic to other areas, L1 routers must forward it to L1, L2 routers. L1 router know about its own area information, its own area, like this. L1 only router will talk to L1, L2 router, that is, it has to send update to L1, L2 router. It does not know about other areas. This is acting like a gateway to reach other areas, right? And this is L1 router only, like it has to talk to L1, L2. L2 router will talk to L1, L2 routers, L1, L2, or it can talk to L2 routers, right? And we have update process, like it uses LSP, link state PDU, or sent reliably means it uses acknowledgement, right? And on PPP link, the receiver will explicitly acknowledge for each LSP it receives with a PSNP, partial sequence number. Partial sequence number it uses PSNP, right? And PSNP, partial sequence number PDU. On broadcast network, the DR will periodically send CSNP, complete sequence number, right? On broadcast network, the receiver will not acknowledge each update. So the DR multicast a CSNP in every 10 seconds that contains a list of LSPs in its database describing their LSP ID, sequence number, checksum, and remaining lifetime, right? So if any router has a newer LSP, it will multicast that. So if any router needs any LSP, it will multicast a request and the DR will respond to that, right? And this is update process, and it uses areas, and we have area ID and system ID, right? Area ID is used to identify areas, and each ISIS, that is router, is uniquely identified by its system ID, similar to OSPF router ID, right? The area ID and the system ID are defined as an ISIS router with a single address known as network entity title, right? So it is like this. We have area ID, a system ID, network selector, right? So this is 0, represented 00 is for routers, and this is system ID, 6 bytes, and this is area ID. Then 49 is basically for private address. So this is network entity title. So like this, we can configure ISIS. So for configuration, we have to go to configuration mode, router, ISIS, then network ID, that is area ID, system ID, that is network entity you have to give. Next, changing router type. So we have L1 and L2 router. For that, we have to give IS type L1, L2, right? And then we have to enable on the interface IP router ISIS. Like this we can configure, and we have example for this configuration. So like this, configuring router A and router B. This is L1 router. So configuration for L1 router, that is router A, is like this. IP address, this is just a loopback interface, and it is LAN interface. IP address, IP router ISIS we have to enable on the interface, and router ISIS IS type level 1, and passive interface is just for loopback, and then network ID, that is. And next for router B, that is L1 and L2 router, here is interface loopback, then LAN interface, right, that is fast Ethernet, IP address, IP router ISIS, then IS circuit type L1, and interface, another interface. So IS router, IS route, IP router, ISIS, IS circuit type L2, right? And then router ISIS, passive interface for loopback, and then network ID. Like this we can configure OSPF. So thanks for this.